same now is the limit as x approaches 1 of 2 minus x. We go ahead and substitute, and we get a limit of 1. So what we're doing is just kind of building up strategies for dealing with these limits when we can't simply substitute. All right, one piece of this left. And now we just have some basic properties that are going to help us evaluate limits. And you really use these when you're given some known information about limits and are asked to calculate the limit of a sum or a product. So let's say that we have two functions, f of x and g of x, where we know that the limit as x approaches a of f of x is L1, and the limit as x approaches a of g of x is L2. Now, my first property says that if I'm taking the limit of a sum, that's the same thing as adding the sum of the limits. In other words, this is going to be the same as the limit as x approaches a of f of x plus the limit as x approaches a, which is 1. So I'm going to write it down here. And the limit as x approaches a of g of x was L2. So it just gives us a way of simplifying those limits. Similarly here, if I have the limit of a difference, that's just equal to the difference of the limits. So this would be L1 minus L2. And those L1 and L2, in a problem like this, you would be given those values. Okay, next we have products. So the limit of a product is the product of the limits. Probably getting the idea pretty quickly here now. Oh, I'm sorry, this should be f of x. I'm getting ahead of myself. So now we have L1 times L2. And I'm writing quickly. If you need to, you might want to pause to get this all down. Now we have quotients. The limit of a quotient is the quotient of the limits. Of g of x, which is just L1 over L2. And of course, that's as long as L2 is not equal to 0. Now, if I have the limit of a root, that's just the same as the root of the limit. And then last, if I have the limit of a constant times the function, that's just the same as the constant times the limit. Okay, so two quick examples, and likely you might encounter this on a multiple choice question on the AP exam. It doesn't come up all that often, but it is important to know how to use these rules. So in our setup, we are given that the limit as x approaches 8 of f of x is negative 9. And the limit as x approaches 8 of g of x is 2. And then we also have a third function. Limit as x approaches 8 of h of x is 4. Sorry, I'm stumbling over my words there. So we're going to use the properties to compute each of the limits. Now, I'm going to show more work than you would likely need to, but I just want to illustrate how we would use these properties. So, first thing I notice is I have the limit of a difference, which we said is the same as the difference of the limits. So we could do the limit as x approaches 8 of 2 times f of x minus the limit as x approaches 8 of 12 times h of x. So the first one we used was our difference property. But now I'm going to use my constant here to move those constants in front. So that's just the same as saying 2 times the limit as x approaches 8 of f of x minus 12 times the limit as x approaches 8 of h of x. Now, since we know these two values from the problem, we're just going to plug those in. So I have 2, the limit as x approaches 8 of f of x was negative 9. minus 12. The limit as x approaches 8 of h of x was 4. So I get negative 18 minus 48, which is going to give us negative 66 if I didn't mess that up. Please feel free to tell me in class tomorrow if I did. Okay, but that's how we use the properties. One last quick example. Again, I ultimately would not expect you to put in, especially these first two steps. I would recommend showing your work here, your arithmetic. In the case that you got the final answer wrong, at least I could see that you had the right thought process going in. So let's see what we've got here. I'm going to skip a step here. I know this is the same as 3 times the limit as x approaches 8 of h of x minus the limit as x approaches 8 of 6. So this first piece, again, the limit as x approaches 8 of h of x is just 4. So I have 3 times 4. Now this one's a little different. The limit as x approaches 8 of 6. What we need to realize is this is just saying I have a constant function. So if this were my axis and this were 6, my function is just y equals 6. So really, no matter what value I approach, that limit is always going to be 6. So then I'm just subtracting 6. So 12 minus 6 gives me a value of 6. All right, obviously this is going to take a lot of practice to get all these techniques down, but we wanted to give you kind of an overview of all of them to get you going. All right, I will see you in class. Have a great weekend.